I'm Mark Rexler with the Climate Web, and we've recently added to the Climate Web the latest update of the Actuaries Climate Index. And in this video, I'll quickly explain to you what it says and why it matters. So the Actuaries Climate Index is looking at the past. It does not do any forecasting of climate change of any kind because it's actuarial. It uses the period of 1960 to 1990 as a baseline average, and then measures how a whole series of variables have changed and are changing since then. So this is the composite Actuaries Climate Index from 1960 to the second quarter of 2022. And one thing to notice is that the scale here is in standard deviations. So you take the average, you create a normal distribution for the period 1960 to 1990, and then you can say, how has that changed in terms of the standard deviations away from that average over time? And this composite includes 6 different variables. And so I'm actually going to zero in on just a couple of those variables that are perhaps the most interesting ones. So this is the warm temperature index, which takes a look at the frequency of daily temperatures above the 90th percentile. And again, that's the 90th percentile for the 1961 to 1990 baseline period. And you can see there's obviously a lot of change here. In some quarters, we've seen variations of 4 standard deviations from the mean, which is a lot. But the overall average, you can see the line there, we're at about 1.5 standard deviations in terms of the overall average across all the different quarters, because there is quite a bit of variation quarter to quarter. So this tells you something about what's going on with warm temperatures. And the corollary to that is what's going on with colder temperatures. And the colder temperatures graphic talks about the frequency of daily temperatures below the 10th percentile for the 1961 to 1990 baseline. And you can see it's as dramatic as the warmer temperatures composite index was. And that suggests that the normal today is not the normal that we had in 1961 to 1990. And the overall probability distribution of temperatures and perhaps other climate variables is likely to be shifting. Now, that's not a surprise. We would expect the overall probability distribution to change over time with climate change. And there are a lot of complexities here in terms of assuming a normal distribution versus some other kind of distribution. But for the basic point of what the Actuarial Climate Index is trying to get across, this is sufficient. It's also not a new idea. Climate scientist James Hansen for many years has been doing something very similar, in this case, tracking in the top row, tracking the shifting distribution of temperature anomalies in the Northern Hemisphere, in this case, basically for the June, July, August period. And you can see he too normalized those temperature anomalies for 1951 to 1980 in his case, and then has been tracking what's going on and basically shows approximately a 1 or 1.5 standard deviation change by the period 2005 to 2015. So there's plenty of evidence out there that these distributions are changing, but what's probably a bit counterintuitive is how significant a relatively small change in the standard deviation can make. And that's why I've included this slide. And again, these are based on normal distributions, so you can't literally apply them to the same data sets. But to give you a sense of the impact of a 1 standard deviations shift, if you go from a 6 standard deviation event that you would expect to happen every 1.4 million years, twice in human history, that would now turn into a 5 standard deviation event, which you would expect every 4,800 years. And if you went from a 5 standard deviation event expected every 4,800 years or once in recorded history, it would become a 4 standard deviation event expected every 43 years. And down at the other end, what was a 3 standard deviation event expected once a year would become a 2 standard deviation event expected every 3 weeks. So 1 standard deviation shift of the overall probability distribution makes a huge difference in what we might expect to see in terms of the frequency of the kinds of events that otherwise would be quite infrequent. Now, one of the cool things that you can do with the Actuaries Climate Index is map out and visualize the changes in a more direct way than you can with the graphics that I've already showed you. So you can go in, you can select US or Canada by region, which is what this particular graphic is set up. You can select which component you want to take a look at, whether the overall index or the warm temperature index, cold temperature, extreme wind index, all the different indexes. And then you can play that out on the map. And so here I've selected the warm temperature index for USA and Canada by region. I've set it to play fast, so it'll go relatively quickly. And again, what you're seeing is the change in standard deviations from quarter to quarter for each region. And it's notable because different regions in the US and Canada can be doing very different things. And so it's interesting to look at it from a regional perspective. Remember that 1961 to 1990 is the mean. And so you would tend to see some variation around that mean, but then you'll tend to see more of a signal after that mean. And that's exactly what happens. So let's go ahead and click on it. And so it's moving along 1960s, some cooler periods, some warmer periods in certain regions, pretty consistent across the US and Canada. We're getting into almost 1980. So we're starting to see a little more in terms of warmer temperatures, around 1 standard deviation, half to 1. Now we're getting into 1 to 1.5 standard deviations showing up pretty regularly. We're now at 2000. And it continues from there. You're seeing very few colder periods, none, in fact. And you're seeing quite a skew towards warmer. And there you might have seen it right there. Let me just back up for a second. Right here, you've actually got periods in the Southwest and in Canada in the Northwest where you're more than 2 standard deviations off the mean, which is a very big number that happened in the summer of 2019. And so we can continue to watch this play out. And so there is variation that at the very end, the last quarter, we're not at more than 2 standard deviations anywhere for pretty much everywhere in the US, with one exception in the Midwest. We're at 1 to 1.49 standard deviations away from the mean. So this is a pretty significant change. And if we jump back to this slide, you can stop the video, take a look. You can get a sense of just how significant a change it is. Again, it's a bit complex in terms of assuming a normal distribution when things probably aren't actually a normal distribution. But for purposes of thinking about climate risk and the future of climate change, the new normal is quite different than the normal 50 years ago. And there's every reason to believe that this will continue apace and that the future normals will be very different from today's normal. I hope that update to the Actuaries Climate Index was useful. It's one of hundreds of things we're constantly adding to the climate web on an almost daily basis, and I hope you'll check it out. Thanks for watching.